General relativity, step by step. Last time I was considering the linearized Einstein field equations, and I was using them to show that waves moved at the speed of light, basically because my vector k was a null vector. Well, that's great. I'm going to carry on using similar techniques to have a look at the term a mu nu e to the I k alpha x alpha. We've pinned down, or we've said something about that term there. What I'm going to do now is to think about this term here, because I don't know anything about it from that term. You'll remember that I used the Lorentz gauge condition, which basically says di mu h bar mu nu equals 0. That's the Lorentz condition, Lorentz gauge condition. And I could always ensure that that was true by the right kind of gauge transformation, which I showed a few screencasts ago. So what I'm going to do is I'm just going to whack it in and see what I can learn about the A matrix, the A vector. Sorry, this A tensor here. Well, it says di mu acting on A mu nu e to the I k alpha x alpha close square brackets equals 0. Well, that's great. Now, I specified all along that this thing here is constant. Actually, I'm going to write out a sum over mu. I'm going to write it out explicitly. It just makes things a little bit clearer what's going on. Now, because it's constant, because the A matrix is constant, it commutes past the differential. Of course, I can't take it all the way outside. It doesn't go past the summation because there's a mu in it. So it's the sum over mu of A mu nu di mu e I k alpha x alpha. And it's the same argument that equals 0. And it's the same argument as last time. It's the sum over mu of A mu nu times the di mu just picks out the it picks out the component of this sum here, which is equal to mu. So it's k mu e to the I k alpha x alpha, and that whole thing equals 0. This thing here, and come to think of it, that I there, that's never equal to 0, and this thing here is never equal to 0 because the modulus of it equals 1. So that tells me that sigma A mu nu k mu equals 0. And of course, I'm just going to get sigma over mu. So I'm going to use the Einstein summation convention again and just write that down equal to 0. Well, that's nice. That's a nice little equation there. That's quite nice, isn't it? So what have we got so far? We've got this one here, and we've also got that k is a null vector equals 0. And we've also got this relationship, this rather peculiar relationship between the A matrix here and k. It's kind of perpendicular to it in some sense. Yeah, we'll return to this a little bit later. We'll use this to simplify our solutions and make sure that our solutions are as simple as they can be. I think that's quite nice. I'm going to stop there. Stop.